Hey guys, welcome to lesson 2 of unit 3 of Algebra 1. We're going to be talking about zeros of linear functions. At least that's what the lesson is entitled. I think probably a better description in a lot of ways would be interpreting linear functions. Excuse me. We're going to talk about what zeros are and all that kind of stuff. We're going to basically teach this whole lesson through a single example, which looks like this, right? There's our example. And we're gonna hit several different kind of details along the way about linear functions with this one example. So let's dive in and look at this example. Emily is going to a local carnival. The function m equals 20 minus 0.75r represents the amount. We tried to sneak that into one word. What has happened? Let's fix it. Looks good. So much better. The amount of M she had, the amount of, should say money M. I don't know. It should say money M. I'm not going to worry about mess because that's going to mess everything up. It's all right. We're not going to worry about it. Of money M she has left after R rides. Find the zero and describe what it means in the context of this situation. Identify the domain and range and describe their significance. So there's a couple of different things in here. First of all, we talked about domain and range before back in unit 2, I believe. So we talked about those. We're going to kind of put some meat on that and kind of put that into a word problem. We're going to talk about domain of this function in the context of this problem, because a lot of times the domain and the range are different in the problem than they are in kind of the abstract function. Because if we were to just graph the function m equals 20 minus 0.75r, then it would be a straight line. It would be a straight line looking something like this. That's not at all remotely accurate. That's kind of really junky version of a graph, right? But it's going to look something like that if we were to graph it. And what those arrows mean at the end of that is that it goes on forever, right? And so the domain would be all real numbers, everything. The range, what can y be, would also be all real numbers. The domain, I kind of skirted past that, but as a point of review, the domain, remember, is what x can be, and the range is what y can be. And so if we were to graph just this without all of the the problem itself, the domain and range would both be all real numbers. But that's not particularly useful in a problem like this. And in a problem like this, our domain and range are actually a little bit more limited. Let's see if we can walk through the pieces of the puzzle. So first of all, what is a zero? So a zero, as I should do this a different color. A zero, as you might expect from context, is where something's zero. That makes sense, right? And so zeros are another name for the X-intercept or intercepts. In linear functions, there's only one. So there's not multiple. Sometimes the functions there's more than one. So we're going to put X-intercept. Or s, right, in parentheses. So there might be one or there might be more than one. In this context, there's one on linear functions, right? So it's the same as that. That's all we're talking about. We're talking about zeros. When we're asked, good grief, we're asked to find zeros, we're asked to find the X-intercepts, and that's all there is to it. So how do we find X-intercepts algebraically, right? Well, we write down the function m equals 20 minus 0.75r. So we set y equal to 0. Now, what is y in this one? Well, the y is this one by itself. So we're going to set that equal to 0. And then we're going to solve for r. R is because remember, x is the independent variable, right? R is the one that's controlling the other. The number of rides she rides controls how much money she has left. Her money depends on the number of rides she's ridden. So R is the independent variable, so it's X. So that's what we're looking for, right? So 0 equals 20 minus 0.75r, right? And so we're going to solve this guy. So we're going to subtract 20 from both sides. Those cancel, leaving us with negative 20 equals negative 0.75r. Then we got to divide that negative 0.75 off. Divide it from this side and then divide it from that side. Okay. Then what we get for r on this one is, that says 26, which I think is right. Let me double check that. So it was right-ish. So it ends up being positive, right? Because we've got negative divided by negative. Positive 26.666 repeating, basically, right? Keep on repeating that thing on out to infinity. So 26.67, right, is what we end up getting there, right? So hence the 27 that I was looking at over there off camera, right? Now, so that's going to be wherever that is. Now so we can graph this thing, so we can kind of think about what's going on here. Let's find the other intercept. So let's find the Y-intercept, or the M-intercept in this case, right? So we're going to put a 0 in for r, which what's going to happen, right, is this is just going to cancel. So the M is going to equal 20. So now we're asked to describe what it means in context. So we're going to graph this. Now I've got some graph paper behind behind all this work. Now, so what we're going to first do is we're going to graph this kind of in a single quadrant, and we're going to explain why. So I don't have any axes drawn on here, which was intentional. I didn't just choose the wrong file or something, right? So let's first start by labeling our axes here. So our x-axis, or our r-axis, is rides, right? The number of rides she's ridden. Okay. And the y-axis, or the m-axis in this context, is the money axis. So her money starts out at $20. So I'm gonna count by fives here. As I think that's gonna be reasonable. Get us a good looking graph. 5, 10, 15, 20. I'm gonna count by fives on that axis. And then I think, I'm counting by fives again on the rides axis is fine. You do not always have to count by the same things, by the way. That's something worth noting, that in some situations, we don't want to count by the same thing on both axes. So now we're going to plot some points, plot our intercepts, right? So we're going to put a dot right here. And then at 26 and a bit, so that'd be about right there. So here to there is our graph. So there it's graphed. So what we want to know is, now what the problem is, I'm going to go ahead and talk about two different things. Oh, well, this will get domain and range as well. So the problem wants to know, what does the 0 mean? So this point right here is what it's asking about. So what does the 0 mean? So the 0 is, in this case, is when she runs out of money. Equals no money. No more money. No more money. That's what the 0 means in this problem. So what is the domain in this problem? The domain is what x can be, or in this case, what r can be. The domain runs everywhere from 0 to 26.7. Now, 26.7, she can't ride a third of a ride, so she's actually only going to be able to ride 26 rides, right? So that's all that she can ride on this. So the domain is everything between 0 and 26. So she could ride 0 rides if she gets there and decides, nah, I'm done. Or she could ride up to 26 rides, right? The range on this, the range of values, and what does the domain mean? I'd basically talk through that. The domain is the number of possible rides she has, right? The range is down to $0. It's actually not quite $0, right? Because she's going to have a little tiny bit of change left, right? Because she's going to have a third left, third of $1, right? So we'll say it's not including 0, and we're doing M, right? And it goes up to $20 and that's what the range represents in this particular problem. It represents how much money she has from her highest amount of money of $20 down to almost $0. So that's kind of interpreting linear functions with a single example. Hope you've enjoyed this video. If you're one of my students, do your homework, see you in class, all the things. There'll be less practice problems on this one. At least that's my current plan. We shall see. I don't know. I might throw more than what I was thinking. But if you're not one of my students, thank you for joining us. This entire course, the lecture portion at least, is available for free here on YouTube. Because of that, we would really appreciate it if you'd hit that subscribe button and the like button, because that really helps us out. It helps us be able to continue to offer these things to you guys for free. Thank you guys. Have a great day. Check out emberlearninglabs.com for everything else we're doing. Bye-bye.